Hello, and welcome to Ancelus spacing training. In this session, we're going to deal with the all-important list field structures in the database. We actually have 4 different list fields that we support. We support an item list structure, we support a key list structure, we support a foreign key list, and a concatenated key list. Concatenated key list. Now, the most common of these is the key list structure. Key list is just what it sounds like. It's a linked list of keys owned by another key. It has one important feature, and that is once you link in a key, it cannot be linked in again. The lists are unique. And I think you'll see that the example that we use, it makes obvious sense that we want this to be a unique list. Now, in a future session, we're going to relax that requirement. And in fact, when we look at foreign key lists, you'll see that limitation goes away. But what would we like to do with a key list? We're going to create a very simple database. It's going to have part numbers, it's going to have serial numbers, and for every serial number there's going to be one part number, and for every part number there's going to be a list of serial numbers. We'll start off by just making we'll make a 100 megabyte database, room for 20 data dictionary elements or fields. We're only going to use 4. Oh, by the way, if we run out of data dictionary elements, it's very easy to extend that. That's not an issue. We'll start off by making our part number key. So the name is going to be PN, part number. Its type is key. The format is going to be character. We're going to have 40 characters for every part number. And we're going to make room for 1,000 part numbers in our part number serial number database. Next, we'll create our serial number key. The name is going to be SN, serial number. Type is a key. Format is character. And we're going to say that each serial number is 32 characters. And we're going to make room for 1.5 million serial numbers. Next, we're going to create a foreign key in the serial number table, which is the part number for the serial number. And we're going to call it PN for SN. Type is KP for key pointer. Key pointer is our terminology for a foreign key. We need to define 2 things in a foreign key field. We need to say who owns the foreign key and what is the key that it points to. What is the key that it references? So we're going to say the owner is serial number. That's who's going to own this foreign key. And the point is PN, point is part number. That's the key that the foreign key references. Now, here's the linked list field. We're going to have a field called SNs for PN, serial numbers for part number. The type is KL, a key list. All we need to define in the key list structure is an owner. It's owned by the part number table. The key that it references, point equals serial number, and we create the linked list. Now, there's no depth to a linked list. There's no format of a linked list. A linked list is purely relationship information. It inherits the depths from the fields that it owns and the fields that it points to. Oh, by the way, if you're clever and notice I'm putting a 40-character part number in my serial number table. My serial number is 32 characters. 40 plus 32, that's 72 characters. And my depth is 1.5 million, and that's bigger than 100 megabyte. How could that be? Well, you remember from an earlier session that a foreign key is not data. The foreign key is a row in the serial number table. The part number is is going to be a row in the serial number table, and that's 4 bytes. So instead of 40 bytes, we're going to use up 4 bytes for every foreign key entry in the serial number table. So there's a 10-to-1 compression ratio. Now, how do we create this database? What we're going to do is we're going to use our little AT-build utility. And just for the fun of it, you know what, let's go ahead and we'll time this little utility. I don't know that this is important. It's a small database. And we're going to send our schema file to it, and it's pn_sn.df. And if I do that, it comes back and says it took 57 milliseconds to create that database. So here's our database. 1,000 part numbers, 1.5 million serial numbers. Both of these are empty. There's no data in this, but we have room for that many part number and serial numbers. So, obviously, how do I get some part numbers and serial numbers, and most importantly, how do I get some information into the linked list of serial numbers for each part number? We'll do that by writing a very small little program, which we're going to call keylist. We'll include our include file. We'll open the database, and we're going to need 4 different fields. Pretty obvious. We're going to need a part number field. We're going to need a serial number field. We're going to need a serial number part number field. That's the foreign key. And we're going to need a part number underscore serial number. That's going to be our field that holds the linked list of serial numbers for a part number. So we associate those field property structures with the actual database fields using ATDB new field. Give the database and the name of the field. Now, we'd like to insert something into the part number table. We've seen this before. Very simple. I'm going to use ATDB load buff to put, and I'm going to hard code a part number into my part number field properties. And then I'm going to call ATDB insert. It's important here to realize when this insert succeeds, it's going to return to us the row that it found available to put this information. So it's going to return a part number row. We're certainly going to use that information in subsequent calls. So the next thing I'm going to do is I'm going to insert serial number, exactly the same routine, ATDB load buff serial number, insert the serial number. The serial number, when the insert succeeds, is going to return us a serial number row. We are absolutely going to use that serial number row for the next couple of calls. So now I would like to insert a foreign key into the serial number table, which is the part number associated with that serial number. We're going to use this utility, ATDB set point. This is sort of the version of load buff that works with rows. So I would like to insert the part number row into the foreign key serial number underscore part number. And then I have to say which serial number is going to receive this part number, and that's the serial number row. So the serial number part number row equals SN row. That's the row returned when my insert into serial number was successful, and I use ATDB put to put the foreign key into the serial number table. We use put rather than insert because really a foreign key is just an item in a table. Now, here is where we add an element to the linked list of serial numbers for the part numbers. I have this field property called PN __SN. I have to define the owner row and the row. First I say the owner row, which part number is to receive this serial number? And that is the result of the part number insert, the part number row. Then I have to say which serial number am I going to insert into this list? And the answer is, so the part number serial number row is the serial number row. That was the result of the serial number insert. Now I can actually insert something into the linked list. When this insert is successful, I will now have a serial number in the list for the part numbers. Now, what I'll do is I'm going to add another serial number just so that it really is a list. I'll insert a serial number, Successful call, I'm going to set that into the linked, or the foreign key for the serial number. Do ATDB put on that, and again, as before, I'm going to define the owner row and the row for the linked list, and I'm going to do an insert into the part number serial number list. So what does that look like? So just for the fun of it, let's go ahead and just compile this. I have to say, where do I find my include file? Then I'm going to add in my source code. I need 3 libraries. And the name of the program. So I've now compiled that. I have a database that has nothing in it. If I execute my program, I now have 1 part number and 2 serial numbers. I can actually show the serial number table using ATShow. You'll find that there's 2 columns in the serial number table. Here is the serial number column. There are 2 serial numbers. And here is the part number for serial number. They're both the same part number. So both of the inserted serial numbers are associated with the same part number. But how do I get access to the linked list of serial numbers for a part number? Well, we're going to write a very simple utility that can actually extract the information out of the list of serial numbers for the part number. In this case, I only need 3 fields. I need the part number field, I need the serial number field, and I need the linked list field. And what I'm going to do is I'm going to go into a loop and say for all part numbers. Now, we only have 1 part number in this database, but let's assume there might be many, many part numbers in this database, each of which might have many, many serial numbers. So I'm going to actually go into a loop and say, give me all the part numbers in this database. I do that by saying, where do I start this list of part numbers? I'm going to set the part number row to 0. By the way, you could set it to the end, you could set it to the middle, but that's for a different session. So I'm going to run through a loop that says, while my ATDB next call on part number is successful, then what I'm going to do is I'm going to print out the part number. I'll use ATDB unload buff to convert the buffer structure into a printable string. It turns out it was already a printable string. It was character data. Now, in order to walk the linked list of serial numbers for the part numbers, I have to once again define the owner row and the row. Now, the owner row is the part number row. The part number row was defined when I had a successful next call on part number. So which part number am I going to use for the list? And the answer is the part number that was returned in the next call for part number. Now, where do I want to start this list? And the answer is we're going to start this list at the beginning. Here again, the serial number, we're going to set the serial number row to 0. Now I'm going to do a next call, and the next call is going to define a row, which is a serial number row. When the next call is successful, the part number __ serial number row structure will be returned, and that is a valid serial number row. I'm going to use that to set the serial number row in the serial number field properties, and I'm going to do a get on the serial number. And I'm going to print out the serial number. I'll print out with a little indentation just so that you can see the difference. Very, very simple. What? 15 lines of code. So what does that look like now? So if I come over here and execute my keylist2 program, let's try that again, /. What I see is a part number, first part number answered, and for that part number there are 2 serial numbers. So I have successfully walked the list of serial numbers for a part number. We won't time this one, but we'll in the separate sessions when we're actually walking large numbers of lists for the part number, we'll actually do some timings. So here we have a very simple database that has a key lists field in the database. We've loaded the primary keys and we've loaded the key list with a simple utility. We've actually written a program that can query the list structure for the part numbers, serial number list for the part numbers. In the next session, we're going to see how we don't need to write a program at all to load these structures. There's a way to do it with some utilities. But it was informative to say, how do we actually deal with these structures directly using the application programming interface, the API. This ends this session. We will see future sessions will deal with the other linked list structures in the database. You'll see some similarities and some differences. For now, thank you for watching.